Okay, so this is the Unit 5 review. Just for those who were absent, I'm sorry you weren't here. It won't be as easy because you won't be able to ask questions, but at least this is something to help you get ready for the test. So, sorry I didn't get this out earlier. So these are the things that you need to make sure you know how to do on the test. Given a graph, make sure you can identify the x-intercepts, y-intercepts, axis of symmetry, vertex, max or min value, the x value that maximizes or minimizes the function, and domain range and the function, and where the function is increasing or decreasing. So everything is, basically everything that's covered from A through K for problem number 2. Okay? And then we also need to be able to write the equations in all 3 forms giving a graph. All right? And most of the test is going to be focused on like example number 2. All right? So you also need to be able to, given an equation, be able to switch forms to all three forms, and find the vertex and the intercepts. So we'll go over some of these things and make sure you feel comfortable. Number 1, you'll need to write down all 3 forms and find 2 key features for each. All right, so make sure you can memorize these key features. All the forms, the 3 forms. So standard form is y equals ax squared plus bx plus c. Y-intercept is y equals a x minus p, x minus q, and the order of p and q, I don't mind if you have them switched, although p and q are in order in the alphabet, so that kind of helps. And then there's vertex form, y equals a x minus h squared plus k. All right. So once you have those, it's really important that you memorize these because it makes it a lot easier on the test not to have to worry about switching signs and things like that. Everything is just taken care of in the equation. So and we'll go over that some more. So next it says write down 2 key features that are easy to identify in each of the 3 forms. So let's start with vertex. What is something that you can, given an equation like this in vertex form, okay, what is something that we could put on the graph really quick? Okay, and one of those is the vertex. Okay, the vertex is giving, is h comma k. So all you have to do if you have that equation, we just plug those in from our graph, our equation, and then we can put it on our graph, okay, if that makes any sense. Okay, also, let's go to intercept form. Well, the hint here is that it's intercept. So here the things we can learn really quick is the x-intercepts. Okay, and those are p comma 0 and q comma 0. And then standard form, if you recall, I know it's early in the unit, but we talked about what we can find really easy is from our constant c, and that gives us our y-intercept, which is 0 comma c. And then we need to have 2 for each, so the other thing that we haven't talked about yet, and it's in all 3 forms, is a. So you could write something like concave up or down. Okay, this gives us our a. This is an arrow. Okay, a gives us our concave up and down, and we can write that on all 3 of them. Okay, and you'll be good. So make sure you realize these things, memorize them, and prepare to write them down on the test. Okay? So giving that information, and this is one reason why you want to memorize it, is because you can just refer to it so easily and it will help you so much on the test. So given this equation for number 2, y equals negative x squared plus 6x minus 8, find the critical points and sketch a graph of the parabola with 5 points. After that, write the above equation in all 3 forms. Okay, so I mentioned in class that if you don't like standard form and you want to switch it into another form and then graph and do all this other stuff, I am totally fine with that. On the test, there's not going to be any particular problem that says you have to find this information, A through K, by just looking at in standard form. So if you want to switch it to intercept form or vertex form, you are more than welcome to do that. Okay, but I'm just going to do it assuming that I'm not going to switch it, just so that we can see having all 3 forms. So this is standard form. Number 3, we do intercept form, and problem 4, we do vertex form. Okay, so giving that, what we want to do, what we always want to do, giving any form, we want to try and get to the vertex. Because once we have the vertex, we can use our growth pattern and graph. And then once we have it graphed, we can find a lot of information really quick. So we want to find the vertex. Okay? And there's one thing that you also need to memorize, okay, or at least, I mean, it will help you if you want to use it, is, and maybe I'll write it over here with this other stuff that we need to memorize, our axis of symmetry, okay? That will always be x equals negative b over 2a. Okay? So if we can memorize that, and this really is when you have standard form, because standard form is the only one that's going to have a b value. Okay? So here we have a equals negative 1, b equals 6, and c equals negative 8. So we know what b is, we know what a is, so we can find our axis of symmetry really quick. So axis of symmetry equals negative b, which is 6, all over 2a. And that gives us 3. So our axis of symmetry is x equals 3. Make sure you write x equals, otherwise it's not a line. Axis of symmetry is a line. So I'll draw this axis of symmetry. Okay? We know that the vertex is on the axis of symmetry. So to find that, all we do is we write 3 comma something, and if we're given an x, like a 3 like here, all we never need to do is plug it into our equation. If you wanted to, you could do a table and do all your x's that you wanted from, I don't know, negative 8, negative 7, all the way to 7 and 8, and you could plug all those values in, and that would give us our y values, okay? And you could graph that way. That would be acceptable. It would take quite a bit of time, but you could do that. So, but really, you want to kind of do that when you have the vertex. When we have x and we want to find y, we'll just plug it into our equation. So I'm just going to do it right here. Y equals negative 3 squared plus 6 times 3 minus 8. Simplify that. Minus 9 plus 18 minus 8, and that gives us 1. So our vertex is 3, 1. Okay? So just a reminder, if you have it in standard form, the first thing you're going to go to is do our axis of symmetry, and then our vertex. And then, so that's like 1, 2, and then 3 will be your growth. Okay, and like I said, you can switch our form into a different form, and you can do it different, okay? You can get that to vertex form for our equation here, then you could do it just using that. So whatever you'd like. Okay, so now we're going to use our growth. Looking at here, what is our A? A is our, we already wrote that here, is -1. So we go over 1, down 1. Over 1, down 3. Just a reminder, growth pattern. Growth is always 1A, 3A. So here we have 1 times -1 is -1. And 3 times -1 is -3. So we'll go over 1, and then it's -1, so we go down 1. Over 1, and then it's -3, so we go down 3. And we do it on both sides. And if you wanted to go further, you could do 5A. Okay, and you'd go over 1, down 5 on both sides. Like I said, you only need to do 5 points. Right? So, now we can pretty much figure out everything else. So, X-intercepts, well, we have one at 2, 0 and 4, 0. Okay, y-intercept is where the graph crosses the y-axis, so that would be 0, -8. Is the vertex a maximum or a min? It's a max. This is the maximum value, which is negative or +1. So how do you know that it's a max? The graph is concave down. The max value is 1. The x value that gives us that highest value is x equals 3. Domain, you can always write it like that. You could write it as this, or you could write it as this. Okay? All acceptable. And it will always be the same. Okay? Range will change. So range is based on the y-axis, whereas h, j, and k, those are all x-axis. Thus we see the x's there. So range, you could write it as you start at the lowest value and you go to as high as it can go. So the range will go from -infinity all the way to 1. And we'll do a square bracket because 1 is included. You can also write this and say it is going to be y, all y values that are less than or equal to 1. So that would be acceptable as well. Where it is increasing. So increasing, you could also say, where is the slope positive? Positive slope. Okay, so positive slope, starting from the x-axis, negative x-axis, going all the way until the vertex, that is increasing. So the slope is positive all the way until you get the axis of symmetry. So you would say -infinity all the way to 3. You could also write that as x less than 3. And then decreasing, it goes from 3 all the way to infinity. Or you could also write it as x greater than 3. Okay? So some people prefer to do it like these, and some people like to use the infinities. So whichever way you would like, you're great. Okay? All right, so after that, we need to come up with the 3 forms. So I feel like it's always easiest to do intercept form and vertex form first. So let's do intercept form. Intercept form, if you look up what you already memorized for our intercept form, it's a, y equals a. We already know what a is. A is -1. And then we're going to have these 2 parentheses, looking up here again with intercept form, x minus p and x minus q. So it's always going to be x minus something and x minus something. Okay? And this information, I mean, they should call it the X-Intercept form because it's based on the X-Intercept. So all we do is Looking at our x-intercept, this could be our P and this could be our Q, or vice versa. You could switch those, it'd be fine. So all we're going to do is plug those into the equation. So we put 2 in and we put 4 in. Okay? If you have the equation memorized for the intercept form, and notice that there are these negatives in here, if you have those written down when you plug in the x-intercepts, you don't have to worry about switching the forms, or switching the signs, okay? It's already taken care of. But if you have it in intercept form, like this, and you just wanted to go straight and do the graph, you just have to memorize that, okay, this is a -2, and it's on here, it's a +2. This is a -4, and this is a +4, okay? All right, and like I said, once you have this all done, you are welcome to plug this into your calculator and check your answer using your graphing calculator, okay? But if you use your graphing calculator to find all this information, I will know, and you will not get points, okay? So, calculator is using for checking, not for finding your answers. Okay, vertex form. Vertex form, again, we need to memorize the vertex, or find out the vertex, and we also need to find A. So A is the same for all three of them, so we're going to have y equals -1, and then we have this, how it's written, plus something, k, and this is our, and here is our h, and here is our k. We just need to find what our h and k are, and that is our vertex. So all we need to do here, we look at our vertex is, this is our vertex 3, 1. We just plug those in, okay? If 3 was negative, then it would be a negative, when you plug it in, it would be a -3, giving us a positive, okay? So just make sure you plug everything in, and you should be good, okay? And then standard form, I told you guys 2 ways to do it. For me, it was the easiest way is to just distribute the intercept form. So let's do that now. So I'll just rewrite it right here. Okay, distribute, that gives us, I'll leave that parenthesis and have the negative. We'll have to distribute that negative later. So we'll do x squared from x to x. We'll do x times -4 is -4x minus 2x and plus 8. All right, so then we distribute that negative. That gives us y equals -x squared plus, when we combine these two, that gives us a -6. And then we simplify with that, or distribute that negative, that gives us a positive 6x and a -8. So our answer is y equals -x squared plus 6x plus, or minus 8. Okay? All right, so there's problem number 1, or number 2. Let's do some more examples. Number 3. So what form is the equation in this problem? Hopefully you can figure that out really fairly quickly. That is intercept form, so we could just write that here. Y equals x plus 4 times x minus 2. All right. You can, from here we can come up with our x-intercepts really easy. So remember, when you go from the equation to our x-intercept, this is where we need to make sure we switch the signs, because when we were solving, we would set, like, say x plus 4 equals 0, and then we would subtract 4 to both sides, and we would get x equals -4. So that's why we kind of have -4, 0, and we would also have +2, 0. So we switch these signs when we plug those in. Okay, so we could plot those here and here, Okay, axis of symmetry would be next. So when we have it in intercept form, we're going to do our this would be number 1, would be our x-intercepts. And then from there we can find our axis of symmetries. And then from there we can find our vertex. So axis of symmetry will always be right in between those 2 points because the parabola is symmetric. So we'd have x equals -1. Our vertex will be -1 comma something. And just remember, if we have an x and we want to find the y that corresponds to it, we will plug that into our original equation. So y equals -1 plus 4 and -1 minus 2, which is 3 times -3, that is -9. Okay, so the graph would be like right here on the graph. All right, and then after that, you will do your growth pattern. Once you have the vertex, you always do the growth pattern. So we go over 1, A is already here. A equals, which is would be in front of that parenthesis. If there's nothing, then it would just be 1. So over 1, up 1, over 1, up 3, over 1, up 5, which is already there. And we do it on the other side as well. Okay, and then from there you should be able to come up with everything else. Y-intercept, we look at the graph where the graph crosses the y-axis. That is 0, -8. Is there a maximum or a minimum at the vertex? Well, it's a min. And how do you know? Concave up. And what is that minimum value? -9. And what's the x value that gives you that -9? It is -1. Domain, okay, same thing as last time. You can write it in either of those 3 answers. Range is all y values that are greater than or equal to -9. And where is the graph increasing or where the slope is positive? Well, it would be all x values that are greater than -1, and it's decreasing for all x that are less than -1. Okay? Or like I said, you could write it as increasing is from -1 to infinity and -infinity to -1. Those are the same. Okay? Same as the range, you could write it as -9 to infinity. All right, so we want to find the standard form. So the easiest way to do that is to distribute intercept form. So I'm going to distribute. That gives us y equals x squared minus 2x plus 4x minus 8. Combine like terms. That gives us y equals x squared plus 2x minus 8. Vertex form. So I'm going to go over this and do it the other way. So you could do it using the graph and just plugging stuff in. But this is another way, whichever you prefer. Just want to give you guys options. And you're not required to do it in any particular way. So vertex form, we learned in 5.2, I think, that we can find the axis of symmetry using -b over 2a. That gives us a -2 over 2 times 1, which is -1. Okay, and then if we want to find the y value that corresponds to that x, we just plug that in. So we want, basically what we're doing here is we're trying to find the vertex. And if we have the vertex, then we can plug that into our vertex form. So we plug -1 into our equation. You could use you could use standard form, plug those in, or you could plug it into intercept form. I'm going to plug it into intercept form. So that gives us -1 comma 4, or not comma, plus 4, and minus 2, which is what we already did. But if you were just given the equation, this is what you would do. And that still gives us negative 9. So once we have that and we have our growth pattern, which a equals 1, we can write our equation. Y equals 1, x minus, and so x is, for our vertex, I'm going to just rewrite it here. Vertex is negative 1, negative 9, okay? So we'll plug that negative 1 into here, giving that be a positive squared minus 9, okay? All right, so basically what we did already, but if you were given an equation and you didn't have the graph, then you could just use access to symmetry and then find the y value to give us our vertex and then plug it into our vertex form. Okay? All right, so 4. What form is that equation in? That is in vertex form. So we'd write y equals 2 times x plus 5 squared minus 2. Okay? If you wanted to find standard form from there, you could distribute. So I'm just going to do that for you guys. Y equals 2 times x plus 5 times x plus 5, because this, what we have here, squared, is the same thing as this. Okay? Oops, my bad. All right, and then we have minus 2. So all we need to do is distribute. That gives us y equals 2 times x squared plus 5x plus 5x plus 25 minus 2. Okay, and then we distribute that 2 to all these terms. That gives us y equals 2x squared plus 10x plus 10x plus 50 minus 2, and then we combine like terms. Okay, you could have combined these 5 and 5x, 5x, you could add those, combine those earlier if you wanted to. Okay, and that gives us our standard form. So we have y equals 2x squared plus 20x plus 48. And then from there we can do intercept form. So, intercept form, all we need to do is factor. So we could do glasses. You could take out the greatest common factor first, if you wanted to. Or you can not take it out and do it the long way. Okay, that's a 24. Okay, and then from there you would do glasses, we do 24 and 10, and that would give us 4 and 6. And so our intercept form would be 2 times x plus 4 and x plus 6. So when you're switching forms that way, you don't ever have to worry about switching signs or anything like that. Okay. All right, so I just kind of did it backwards. So if you wanted to do it that way, that's just fine. And then you could use that information to find the vertex and things like that. So here we already can tell with our intercept form where our x-intercepts are. Okay. Or if you were given this equation in vertex form, then what I would do is I would write the vertex first. It will be -5, -2. Okay, so that 5 comes in here, and you have to switch the signs when you take it from an equation to a graph. Okay, so -5, -2, and then growth pattern. A equals 2, so we'll go over 1 up 2, over 1 up 6 on both sides. Okay, Now we can write down what our x-intercept is as well. So we could use it as the equation that we already did, or we can just write them down after you graph it. So we do -6, 0 and -4, 0. Y-intercepts. Like I said, if you know with y-intercept our x is 0, if you wanted to find out what the y value is, we can just plug it into our original equation. Or if we already have it in standard form, it's always going to be 0, c. So you could write 48 in there if you'd like. Axis of symmetry. Axis of symmetry is the x value in our vertex. So x equals -5. Is there a vertex, a max or a min? It's a min. How do you know? Concave up. What is that min value? -2. That's the lowest value on that graph is -2. And then the x value that gives you that minimum is going to be our -5. Domain is still always be the same. Do that R or any of the other ways you could write it. Range, so it's going to be all y values that are greater than or equal to -2. Okay, and where is the graph increasing? We could always write x, and increasing, we look here, it starts at -5 and to infinity, so it's all x values greater than -5, and it's decreasing for all x greater than -5. Okay? All right, so that covers that. Any questions, let me know. Okay, next one. So people have asked questions about this. What form is this in? So if you have a parenthesis that's not squared, but you do have a parenthesis, it's always going to be intercept. I totally messed that up. Intercept. Okay. If you had a parenthesis squared, that will always be vertex. And if you have something that's squared that doesn't have any parentheses, that's always going to be standard form. Okay, so this is intercept. You could write it as -2x plus 0 times x plus 4. Okay? Since it's intercept form, we can find these x-intercepts really quick. 0, 0 and -4, 0. Okay? So we plot those. Axis of symmetry will be right in the middle. X equals -2. Vertex is -2, something. To find that vertex part, the y value, we just plug that -2 into our original equation. So y equals -2 times -2 times -2. Lots of -2's plus 4. Simplify. That gives us 4 times 2, which is 8. All right, so that vertex is right here. Vertex. Okay, and then after that, after we have the vertex, we just need to do the growth pattern. So what is A? A equals -2. So over 1, down 2. Over 1, down 6, which is on the x-intercept. Okay. So now we can write down our y-intercept. Y-intercept is where the graph crosses the y-axis, which is 0, 0. And it's okay to have an x-intercept and y-intercept be the same, like these two. Okay. Is the vertex a max or a min? It's a max. How do you know? Concave down. What is that value, the maximum value? Okay, the highest value is 8. And what is the x value that gives you that maximum value? It's -2. Domain, always that. Range, you could say it's from -infinity to 8 with a bracket, or you could just say it's all y values less than or equal to 8. Where is it increasing? It goes from negative infinity to negative 2, okay? Or you could write that as all x values less than 2. And then for decreasing, you could go from negative 2 to infinity, or x greater than 2, okay? I kind of think that, I kind of like this better, but either way is just fine, okay? All right, so we already have the y-intercept, negative 2x, x plus 4. Okay, if we want to have standard form, we can just distribute. Okay, so distribute this to those two terms inside. That will give us y equals negative 2x squared minus 8x. And then vertex form, we know that the vertex is negative 2 comma 8. And we know that a equals negative 2. So we can just plug that into our equation. Y equals negative 2x minus a negative 2, which gives us a positive 2 squared plus 8. All right. Okay. This is 5. I just want to make sure I'm not missing anything out. Okay, that should be great. So if you have any questions, please let me know. Okay. So, and then, just like I said, if you wanted to switch forms, like here we switched forms just by distributing, and then you would go this way, and you could either complete the square, or you could do x equals negative b over 2a, and then find the y value by plugging this x into the equation, and that would give us our vertex for the x comma y from these two, okay? All right, and I think I told you already, so switching forms, giving an equation, say, in standard form and switching it to the other two forms, it won't be worth a whole lot on the test, so it's kind of like a nice-to-know thing, but it's not something that's like very critical, okay? 6, this is basically the same thing, except instead of giving us an equation, we're just giving a graph. So, I mean, you could go straight from this graph and come up with these three forms. Let's do that first. So, intercept form, we need our x-intercepts. What the heck, I'll just write these up here too. So, x-intercept, here we've got negative 1, comma 0, and we also have 3, comma 0. And what is a? We need to have what a is. We go over 1, up 1, a equals 1. So for intercept form, y equals 1. We have these two parentheses. If you remember, the equation is ax minus p and x minus q, where here you could say negative 1 is p and 3 is q. So all we need to do is plug these in. So p is negative 1, so we already have a negative, and then we put in another one that gives us a positive 1. And then here we have a positive 3 for q. We plug that in, and now it's switched to a negative 3. Okay, vertex, we know what the vertex is. We'll just write it up here. Vertex is 1, comma negative 4. We already know what a is, so we can write down our vertex form. Y equals a x minus h squared plus k. All right, so we have y equals 1 times x minus h. H is 1 squared, and h is our vertex, so this is kind of like, you could say that is our h comma k. And then our k is a negative 4, so we add a negative 4. Okay? After that standard form, all I would do is distribute. That gives us y equals x squared. And then a negative 3x minus 3x and a plus x. That gives us a negative 2x. Okay, and then we have negative 3. All right, so we have all those graphs really quick just by using all the forms just using the graph. And then we'll just fill in the other stuff that we haven't done. Y-intercept will always be 0 comma something, and it will be where it crosses the y-axis, so negative 3. Axis of symmetry is the x value in our vertex, so x equals 1. Is the vertex a max or min? It's a min. How do you know? Concave up. A max or min value is a negative 4. And what's the x value that gives you that negative 4? It is 1. Domain, always that. Range is all y values that are greater than or equal to negative 4. Where is it increasing? It is increasing for all x values greater than 1, and it's decreasing for all x values less than 1. Okay? All right, and then all we have left is 7, 8, and 9, which is the same thing as we did in C, except we don't have to write down all of the A through K values. Okay? So, looking at this, vertex form, that's my favorite, so we're going to do that one first. Vertex form, or vertex is negative 1 comma negative 4. And what is A? We go over 1, up 1, so A equals 1. Vertex form, you just have to memorize and then plug it in. Y equals 1 times x minus h, and h is a negative 1, so that gives us a positive 1 squared minus 4. Intercept form. Okay, I mean, if you wanted to, you could just start at vertex form and come up with the other two, or you can just look at the graph. X-intercepts are here and here, so that is negative 3 comma 0 and 1 comma 0. So we can plug that into our equation. Y equals A is 1, and x minus p, so minus a negative 3 gives us a positive 3, and then x minus q, which q here would be maybe 1. Okay, so if you look at this for x-intercepts, it's a negative 3, and you plug it in, and now it's positive. But if you write down the equation, how it's written, p and x minus q, the sign is taken care of. Okay? All right, so finally, standard form. All I would do is distribute an intercept form, and that will give us y equals x squared. This one looks just like, they're like the same problem, they're just like flipped over the y-axis. So then we have, would have negative x plus 3x, so that gives us positive 2x, and then 3 times negative 1 is minus 3. Okay? So we got everything covered for that one. And then we just have 2 more. All 3 forms. Same thing, vertex. I mean, you don't even really need to write down what the vertex is and things like that if you'd like. Okay. A here, you go over 1, down 1. So A equals negative 1. Vertex is negative 2 comma 4. Plug stuff in, you get minus because of the A, and then x minus a negative 2 is a positive 2 squared plus 4. And then intercept form, we have X-intercepts are -4, 0 and 0, 0. And looking at that, that looks a lot like this equation. Oh, close, but not quite. Okay. Because here our A is -1, the other one it was -2. Okay, so we have that information, we just write that in. We'll get A equals -1, and make our two parentheses, X minus, and we plug in these values. So -4, that changes it to a +4, and we have a 0. So you would write down this equation as -x, x plus 4, okay? And then standard form, we would just distribute that -4 to the other two. So that'd be negative, I guess I should write y equals. Don't forget to write the y, otherwise it's not an equation. Y equals -x squared minus 4x. Okay, so we just distributed that -4x over to these two terms. Okay, and then lastly, vertex form. We know what our vertex is. That is right here, -2, -3. Okay, and A. So this one's a little tricky. Let's just zoom in for a second. You'll always go over 1, and then you'll go up until you hit the graph. All right, so this is 3, this is 4, and this is in the middle. So you go, that's like 2.5. So you go over 1 and you go up 1/2. All right. Once you have that, you just write it in vertex form. Y equals 1/2 x minus, and the equation's like that, plus, okay? But since we have a -2 in here, that's going to change it to be a +2. And then we're adding that to a -3, so it's -3. Okay? All right, so hopefully that helps for those who weren't able to be here for the review. And just a reminder, if you were absent for the review, you still have to take the test on test day. And all your homework still needs to be turned in as soon as when you're back, okay? So good luck, and let me know if you have any questions.